Hello and welcome back to Chapter 3.2 Notes for Math 104. We are going to learn about the slope of a line. So in the previous lesson, we did some graphing of equations, and I pointed out what the slope looks like in a graphing situation. And here are the three types of slope. Remember, I mentioned briefly in the last lesson that we read our graphs from left to right, just like we read a book. So from left to right, this is a negative slope because it's appearing to go downhill. This line has zero slope because it's like walking across a room on flat level floor. And then this line has positive slope because it's going uphill. Slope can be thought of in several different ways. And a lot of us have heard that the idea of it's a rise over a run. So it's the rise in your y change versus the run in your x change. If you were going from point P1 to point P2, it's also the difference between your y's over the difference of your x's. I will also show it as the delta y over the delta x, where delta means the word change, delta. Um, And it doesn't matter which point you call point one or point two, as long as you're consistent that, see here where the twos line up, subtracting the ones. That's what's important. So the first one that we're going to look at, the first example says plot pairs of points on the graph and then find the slope of the line through each pair of points below. So let's plot the first one, 3, 1, and 5, 4. So we're going to do A here. 3, 1 is going to be 1, 2, 3. 3, 1 is there, and 5, 4 is for 5. 1, 2, 3, 4. So we're going from 3, 1 to 5, 4. So we have this rise, 1, 2, 3, and we're going to the right 4. So we're going up 3 and to the right 2. Sorry, I misspoke. I said 4. And to the right 2. So, but let's show that up here. So if I call this x1 and y1 and x2 and y2, I can take the change in my y's, which is 4 minus 1 or 3, over the change in my x's, which is 5 minus 3 or 2. And so just like I had here, the vertical change was 3 and the horizontal change was 2, or 3 over 2. Let's look at B. B is the point 1, 3. So to the right 1 and up 3. And then we want to find the point 5, 2. 1, 2, 3, 4, 5, 1, 2. So that is going down. We're going down 1 and then to the right 1, 2, 3, 4. So down 1. I'm going to show that with a negative and then plus 4. Let's show that numerically here. So again, I'm going to call this x1, y1, x2, y2. So 2 subtracting 3. And notice I'm not always taking the largest and subtracting the smallest. I'm starting with 2 and I'm going to subtract 3. So I'm going this way to this way. That means I have to start with 5 and subtract 1. Also, I like to show students, if you turn your paper this way, I have the coordinate 5, 2, just like we have, and I have the coordinate 1, 3, just like we have. That might help you. So this becomes a negative 1 over 4. And that's exactly what we had here, was down 1 plus 4. Then my next set of points, I'm going to do in 2 different colors. So 2, negative 3. So 1, 2, 1, 2, 3. So there is 2, negative 3. And then I want to graph the point 5, 2. 1, 2, 3, 4, 5, 1, 2. So I'm using this point again. So this time I'm going to draw it over here. It doesn't matter if you go up and over, over and up. So I'm going to do my right is 1, 2, 3 plus 3 horizontal X's, and then 1, 2, 3, 4, 5. Up 5. So my slope should be 5 over 3. So I'm going to show that here. For C, it is going to be 2 subtracting a negative 3 over 5 subtracting 2. So 2 subtracting a negative 3 over 5 subtracting 2. So this becomes 2 plus 3, which is 5 over 5 subtracting 2 is 3. So it's just like we said, 5 over 3. Now let's look at D. So D is at the point 2, negative 3. 1, 2, 1, 2, 3. So I'm using that point again, and I'm going to the point 2, 7. So 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So I'm going straight up. So my vertical change is 9, actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A plus 10 over, I don't have any X change. Okay, changing my X's. So let's look at this. It is 7 subtracting a negative 3 over 2 subtracting 2. So it becomes 10 over 0. Whenever you have a 0 in your denominator, it makes the fraction undefined. So this is unique because we can't actually write a value for our slope because the slope is undefined. And that tells us it's a completely vertical line. Vertical line at X equals 2. So there's no slope. Let's dive in some more. So now that we know about the slope of our line, it says find the slope of each of the following lines given the graph. So this is fun because we can just use our vertical and horizontal change. So I'm going to go from here to here. So my vertical change, my change in Y over my change in X is 1, 2, 3. So I went down 3. We're going down 3. And then we're going right 1, 2, positive 2. So my slope is a negative 3/2. The next one, you can visually see that there's no slope and it's 0. It's not like it's vertical, but it's no slope. So the slope is 0. We give slope the letter M, and you'll see that when we start to write our linear equations, we use an M to represent the slope. And then this one, the change in Y over the change in X. So the change in Y, I'm going to start here, and I'm going to go left to right. I'm going down 2. So down 2, and I'm going to the right 1, 2, 3. So just the opposite or reciprocal of what we had in the first one. We went down 3 and to the right 2. And now we're going down 2 and to the right 3. So it's a negative 2/3. Okay. So there's some special lines that we are going to learn about. One of them is a set of parallel lines. Parallel lines are special because they have the same slope. So M1 equals M2, identical slope. Perpendicular lines are a little bit different. Two non-vertical lines are perpendicular if and only if the product of their slopes is a -1. This is the same as saying their slopes are negative reciprocals. So if line 1 is parallel to line 2, then their slopes are equal. If line 1 is perpendicular to line 2, then if we multiply the slope of line 1 to the slope of line 2, we'll get a -1. Or we can also say that if we know the slope of line 1 and we take a negative and then flip over or use the reciprocal of line 1, then that is equal to line 2. Okay. So Let's jump in. It says, find the slope of any line parallel to the line through 2, 5, and 5, 3. So we first have to find the slope of line 1, which is through these two. So I'm going to do a -3 subtracting 5, and then I'm going to do 5 minus 2. So I took a -3 subtracting 5 and 5 minus 2. So this is a -8 over 3. So my slope is a -8 over 3. So parallel slopes would also have a -8 over 3 because parallel lines have the same slope. Now B says, find the slope of any line parallel to the line that goes through these two. So a -6 subtracting a -4 over a -2 subtracting 3. So a -6 plus 4 is a -2 over a -5. So that results in a -2 over -5 is a +2/5. So parallel slopes, parallel lines will have the slope of 2 over 5 because they have the same slope. Before says, find the slope of any line perpendicular to the line through these 2 points. So perpendicular, okay. So the slope of the first line, I'm going to take 1 subtracting 4, and then a -3 subtracting a +3. So we have a -3 over a -6. And that reduces to a positive. A negative divided by a negative is a positive, and 3 over 6 is 1/2. So +1/2. And then the new line, perpendicular. If you do an upside down T, that means perpendicular. So the new line perpendicular, that slope, M2, will be a negative because it has to be the opposite sign, and the old slope was positive, so the new slope is negative. And I'm using the reciprocal. So instead of 1 over 2, it's 2 over 1. Or you can write it as just a -2. D says, find the slope of any line perpendicular to the line through these 2 points. So again, we're looking for perpendicular. So I have to find the first slope. So 7 subtracting a -3 over a -2 subtracting 6. So that'll become 7 plus 3 over a -8, or 10 over a -8. I can reduce that. The negative, it can go on top or bottom. I like to put my negative on top. So it's a -5/4. I'm going to reduce by a multiple of 2. So that means the new line that's perpendicular has a slope that's positive because the first line has a negative slope. They're opposite signs when they're perpendicular, and reciprocals. So I'm going to flip this over. So the new line will have a slope of a +4/5. Okay. Slope and rate of change. Rate of change we talk about when we talk about driving in a car. We talk about how fast we're going. That's a rate of change. How quickly a child grows is also a rate of change. This says, the graph shows the increase in average age of first-time mothers in the U.S. since 1970. Find the slope of the line that connects the points and round to the nearest hundredth. So this is the age of mothers is also a rate of change. The average age of first-time mothers. So back in 1970, the average age of first-time mothers, back in 1975 was the average age was about almost 22 years old. Then in 1990, the average age of a first-time mother was about 24.25. And I was 25 years old when I was a first-time mother. So it did go up, and that was in 1997. So that means year is my X and age is my Y. So my slope is I'm going to take 24.25, subtracting 21.75 over 1990, subtracting 1975. So my change in years is 15 years, and my change here is 2.5. 2.5 years for every, or 2.5 and the average age years versus every 15 years of change. So I'm going to share this and go to Desmos momentarily so that we can do this calculation here. So I'm at the bottom of the screen. I'm going to validate that 24.25 minus 21.75 is 2.5. Yep. And 2.5 divided by 15 is a decimal answer of 0.1666. I want this in fraction form. Notice over on the left in Desmos, it changes this for us to a fraction, which I like. So 1/6. So my slope is 1/6. So every 6 years, the average age increases by 1 year. So this tells us every 6 years, the average age of a first-time mother increases by 1 year. If you'd like to watch the rest of the videos for this lesson, check out the second video available in Canvas.